Hey everybody, this is Larry, this is me going Q2 of the weekly contest for 14th. Maximize score of numbers and ranges. Hit the like button, the subscribe button, join me on Discord. Let me know what you think about this one. So this one, I believe is harder than Q3, though apparently a lot of people solved it very quickly, so maybe that's, But either way, like it doesn't matter which one is harder, it still should be doable. And the idea behind this one is binary search with the answer, right? I honestly, I spent about 6 minutes on this one. A lot of this problem was me just trying to figure out what they're asking for. You can watch the live portion of this, of course, and you can kind of see my confusion, and I talk a lot. But the idea here is that, so you have a score and the minimum absolute difference between any two integers, right? So ignoring the plus d for a second, the minimum absolute difference between two integers must occur with two adjacent integers that are after it is sorted, right? Because after you sort it, then the two numbers that are closest to each other, which is another way of saying this, is going to be just next to each other, right? So that's basically the idea, and we're trying to maximize the gap in between the numbers. So that's maybe another way of thinking about it, is that we're trying to maximize the minimum gap of all the numbers that we can do, right? And I'm not sure. I mean, maybe there are other ways to do it as well. Because I was thinking about like a left-right split kind of thing, but like some sort of. But I don't know. I didn't know how to figure out, or I didn't know how to prove it, to be honest. So I did a binary search. And here, here we have sorting. First of all, I'm going to show you the code. And here is the good function, right? I think the way that I wrote this is actually a little bit more confusing than it needs to be. The reason why I wrote this way is because I didn't want to make a copy of this list, but maybe I should have just made a copy of this list, and then now you don't have to deal with this weird thing with the previous, which kind of added to some complexity. So I'm going to upsolve this live a little bit by creating a new list, right? So here maybe we have let's just say nums is equal to start. Make a copy of start. It's because then now we don't have to worry about manipulating it, right? But yeah, so I'll go over the code once I'm done. No worries, hopefully, right? Yeah. Yeah. Okay. So then now starts up. We add this thing. Okay, so we'll annotate this. So basically, what is a good function, right? Is that can we create I won't say a sequence of numbers, but basically, can we? How do I say this? Can we create a score of target, right? And the way that we do this is in a greedy way, because basically going from left to right, from the smallest number to the largest number, you cannot subtract or do anything, right? With that, so that means that the smallest number you can only add, and as a result, you're kind of forcing the next number, right? Meaning that, for example, if your target, which is the gap, which is the gap, the smallest gap, right? If basically, for example, if you have 3 and 4, like numbers with a gap of 1, but your target is 5, well, you can't change the 3, so you have to change the 4, right? And to make it a 5 gap, you add 4 or something like this, right? So then now the next number is going to be 8 plus whatever, and then you keep going. And of course, there's an additional constraint of this d thing, right? Which is a constant, but basically it just sets a ceiling for what you cannot, or how high you can add up to, right? So that's basically the idea. Yeah, and then with that in mind, we make a copy of start. Oh, let me actually run this real quick before I don't want to, lie to you, because now apparently my code is wrong. Did I make a mistake somewhere? Probably. Hang on. Oh, because I updated start instead of nums. Okay. All right, let me run it real quick. I don't want to show you wrong code, or at least wrong code. Okay. Yeah. So okay. So that means that can we create a score of target, right? So this is so given a certain target, can we create it? So this is a greedy, right? We start from the beginning. If the gap is already bigger than the current target, then we just go to the next number because our job here is done. Otherwise, the delta is basically what the number we have. Increment is what we need to increment, right? So basically, we know that, for example, and you could say this in English, this is basically the gap between this number and the previous number. And if the gap Oh yeah, and here, okay, yeah, I forgot that I have this if statement. That's why I was double checking a bit. But yeah, we know that as a result, if this is true, then we continue. So that means that target is going to be bigger than this number by default. So increment is positive. But basically, as a visualization, if target is 4 and your gap is 2, then now you need to increment the number by 2 so that you could create a gap, right? So that means that if you have like 3 and 4 and you need a gap of 4, then now you up that second number to 7, right? So that you have that gap, and this is basically what this is doing. And of course, you can only go up to D, right? Because you cannot increment by more than D. So this is why we add the smaller number. If the delta is now bigger than the target, then that means it's possible, and we keep going. Otherwise, if that means that we don't the D is not big enough for us to rise, and therefore we return false. Probably could also write this in a different way, but that's fine. Otherwise, we increase num sub I, and yeah, by the difference, we increment it by the increment that we had picked, right? So yeah, and I think it's always going to be increment, because I guess if it's yeah, I think I will just to be consistent here so that I don't have to think about it. But I think if you do think about it, I think it cannot, like, increment will always be true, just because if D is more than increment, then this would have already returned false. So maybe that's a little bit. Let me try that and making sure that I'm not lying to you. Yeah, and prove my AC at least. But yeah, so if it went for all the numbers, and that means that we can create a gap of target between every pairs of adjacent numbers, and then as a result, we do a binary search. The intuition here is that for binary search, if you have a gap of, say, 4, I don't know, this is a random number. I find it a little bit easier to say a real number other than x. But okay, let's start with x, right? That means that if you can create a gap of x between every number, you can always create a gap of x minus 1, right? Because that's just a smaller gap. If you could create a gap of 4, you can always create a gap of 3 and 2 and 1, right? Hopefully that's intuitive. And also equivalently, like if you think about the other direction of going higher, well, if you cannot create a gap of 5, then that means that you cannot create a gap of 6, and you cannot create a gap of 7. It only gets harder, right? To create bigger gaps. So that's basically all you need to do for binary search, and this is how I do my binary search. I'm not going to go over the binary search in detail here. I know a lot of people have templates and all these things. I'm not a fan of it. I should do a separate video on binary search one of these days, but for now, yeah, but for now, this is just the binary search for the answer, right? There's some nuance about getting off by 1 and stuff like this. And I guess it doesn't have to be 10 by 10. It could be just like max of the number of you, which is the biggest number. But is that true? I think that's true. I mean, yeah. Maybe they'll be slightly faster, but it's not a big deal. I don't. Oh, I guess this is not true. So I guess that's it. This is why I usually do something funky, right? This is why I always have something big, so I don't have to. Ooh. Oh. Okay. Well, I mean, I could try a few more, but it's gonna be the biggest number plus D. I suppose. Let's actually test this to be the except bound. It's always tricky to kind of get the precise bound during a contest. During an interview, of course, give it a thought about what you saw was just me kind of doing like very half-second things, but so I don't know. It is what it is, but maybe I don't recommend it. But that's why I had this as a random big number that's gonna be bigger than the biggest possibility by not even just a little bit, by whole magnitude. During a contest is fine, but because it's only gonna be like 2 or 3 times slower. But you know, during an interview you want to be precise, right? So yeah, but that's pretty much it. Yeah, so because the smallest gap is going to be 0, the biggest gap is going to be apparently this, the biggest number, plus the, keeping in mind that we sorted this first, right? So yeah, what is the complexity here, right? Well, this is, how many iterations does this take? Well, it takes the number of bits time, which is up to 10 to the 9, right? So this is going to be O of log 10 to the 9, or log of B, if you will, or R for range, maybe, number of iterations, and this function is, yeah, hopefully obvious, which is linear time. So in total, this is going to be O of n log R time, and O of, in this case, n log R space. But if we had written the other thing with the previous, which you can go back and look at, this is going to be only log R space, but either way it should be fine, right? Oh yeah, that's all I have for this one. Let me know what you think. Yeah, thanks. Oh, I lied because I forgot the sorting. So yeah, so you have to add a n log n here. But yeah, that's all I have for hopefully this is right now, and I didn't misspeak. But that's all I have for this one. I said it at the beginning. Yeah, thanks for watching. And yeah, you could watch me solve it live during the contest next. And there are no zeros. Right, so yeah, okay, let's go. Just want to be careful. I mean, it's not worth 5 minutes to be stupid. And I've made that mistake a lot of times. Alright, let's go. N intervals, choose n integers where the ith integer must belong to the ith interval. The minimum absolute difference between any 2 integers that could have been chosen. Minimum absolute difference, the score. The score of the chosen integers is defined. Okay, the maximum possible score. Minimum. English is hard. Okay, so, oh, D is the same. The score of the chosen integer is minimum absolute difference between 2. So basically, yep, so the score is the minimum thing here, and then the maximum possible score. What does that even mean? Score is fine. So we want the min of these, and then we want the max of. Man, I am not understanding this form, honestly. Okay, but do we have a sweep line thing? Okay, the score. Maximum possible score. So basically we want them to be as spread out as possible, is that right? So that means that we just want some prefix to be, it's a prefix suffix problem, isn't it? So then now, with no changes, the score is going to be I think I get it, but it's such a weirdly phrased problem, I think. Okay, so now that we sort, is it? Can we do a binary search? So, okay, so we want it to be 5. What does that mean? So we add 0, we change this to a 7, okay, and then the minimum is going to be adjacent, so then 7, this is good. All right, so maybe binary search, right? Yeah, okay, fine. Maybe the other thing that I was thinking about doesn't make sense. And we want to maximize, okay. So this is good if, what is good? So it is good if it is possible. So if it's possible, we want to try a bigger number. I always want to try a smaller number. Okay, this is such a, I don't know, maybe I just have thing about it. Okay. First is equal to start of 0, so we never add any number to this one for obvious reason. And for x in let's do it this way. If maybe previous, if starts of I minus starts of I minus 1 is greater than or equal to target, then we're good. Otherwise we have to add some stuff, and adding some stuff is a little bit funky, but oh, this is minus previous. Okay, otherwise what we want to do is okay, so we want this to minus previous to be greater than or equal to target. So that means that if this is less than it, then to get to target we have to add some, so we subtract on both sides, so then target minus this basically the thing is, this is too, the delta is too small, so then now we want to get increment is equal to target minus delta, and then now previous we add min of dinc, right? Oh no, previous is equal to, oh no, we add it. No, starts of I adds it, so then now we have delta, we add this dinc. If delta is less than target, then we return false. Otherwise previous is equal to starts of I plus min of dinc, and return true. Something like this. This is a tricky one to read for sure. 4, 5 looks okay. Wouldn't be surprised either way, to be honest. Okay, wasn't sure about that one, honestly. Oh, this one's easier maybe. I don't know, more people got. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, this video, everything in between. Yeah, and this problem, of course. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.